Alright, so problem 1. Let me get a different pen. So problem 1. So first, we have to compute the mean and median. So for the mean and median, I went ahead and wrote all of the values that are given already. So for the mean, we're gonna add up all of the numbers, and then we will divide by 8. So I'm gonna go ahead and do that now. Alright, so the total of all of those added up is, let's see, 1, 6, 0, 0, 0. So then we're going to get that number and divide by 8. So that's divided by 8, which is 224,500. So that is our mean. Okay. And then next, we're going to find the median. So the median is easy. What I do is I start on the outside and then I'll go like in. So I'll start here and then I go 1, 1, 1, 1. And then since there's 2 right here, we will add these numbers up. So it'll be 1.5 plus, so then it'll be 295. And then we divide that number by 2. So the answer for the median is 147,500. So that's the median. So this is the mean, and this is median. Perfect. And then the number 2 says state which measure better represents a typical house price here. So the typical house price in this case is going to be the 147. It's going to be that median. And that's the typical house price, just because it's the median. So it's the average house price of all of the data points. Yeah. And then number 3, it asks for the outlier. And in this case, the only outlier is going to be that 800,000. And the reason, there's not really, the outlier doesn't really affect any of these answers that much. It's just a lot higher than all of these other prices. So it makes the mean and the median a little different, but especially the mean. So, yeah. Alright, so now we're going to do problem number 2. We're going to be finding the 5 number summary. I went ahead, like the other problem, and I wrote the values down they give us. So let's go ahead and do the easy ones first. So the minimum is going to be, let's see, it's going to be right here. It's going to be at 50. So that minimum 50, and then the maximum is going to be at 95. And then to find the median, we can go ahead and do the, what we did for the other problem. So I'll start here. 1, 1, 1, 1, 1, and then 1. So that median is going to be 70. So let's go ahead and write that down. The minimum is 50, maximum 95, and the median is 70. And then to find Q1 and Q3, for Q1 we're gonna find the median of the lower half. So starting from it'll be between 55 and 68. So let's write those down. So we'll write 55, 60, 62, 65, and 68. And we're gonna write the ones for the upper half too. So we'll do 72, 75, 80, 85, and 95. And then we'll start here, 1, 1, and 62. So 62, and then 1, 1, 1, this one will be 80. So Q1, 62, Q3, 80. And then for number 2, on problem 2, we're going to be finding the IQR. And we'll be using the 1.5 times the IQR rule. So the IQR we find by, it'll be Q3 minus Q1. So it'll be, that'll be 80 minus that 62. 80 minus 62, which is going to give 18. So then you plug that into this formula right here. So it'll be, so then you'll do 1.5 times 18, which gives you 1.5 times 18. That gives you 27. And then next, let's see, I'm looking at the questions. Compute the IQR and identify any suspected outliers using the 1.5 times. Okay, so now we are going to find any outliers. So we will do the median of the lower half which is that's 62, and then the median of the upper half, which is 80. That's what it is. So that'll be 80, and we'll add 27 to this upper half, subtract 27 to this lower half. So 62 minus 27, so that is 45. 80 plus 27, which is 107. Perfect. And then all of the values lie between 35 and 107. So there are, let's see, I'll use this one. So there are no outliers. And also, even if you just look at the numbers, you can tell all of these numbers are within 10 of each other. Like there's not any huge difference between each of these numbers. So that's also one way to look at it and see if there's any outliers. So next, I'm going to draw a box plot. So, starting with the box plot, I'm going to go ahead and do a little outline. Let's see. 1 second. We'll try and keep it as neat as possible. Oops, my God. So we're going to do the median, and the median is going to be the 70 right here. So this is our median, which is easy enough. So it's going to be a line right here. Oh, actually, sorry, I lied. The median is a 70. Sorry. So that's 70, and then we'll do our, what is it? Then we do the Q. We'll do the maximum, which is, this is the maximum, 95, and the minimum is the 55. And let's see. We'll do Q3 and Q1. So that the median of the lower half is going to be 62. So that's where we're going to put our first point. It's going to be, what's that right here? And then the Q3 of, so the median of the upper half is going to be 80. So we'll put one right here. And then we can go ahead and connect these. Also, just ignore this, because that was a little whoopsie-daisy. Alright. And then, let's see where to put my, I had a Sharpie. I don't see my name. Yeah. So I'll use this stuff here. So I'm going to fill this in. Perfect. So this is minimum, maximum. Okay, so I'm going to draw a line here too. Perfect. Alright, let's see. And then that, this is the box plot for it. Describe the shape and skew. So the skew would be, it would be right skewed, because there's more room on this side than this side. So that's my way of thinking about left or right skew. Sorry. Alright, so starting with problem number 3, we're going to be talking about the 68, 95, and 99.7 rule. So starting off, for a normal distribution, I went ahead and actually wrote it down. 68% of the data lies within 1 standard deviation of the mean, 95% lies within 2 standard deviation, and 99.7% lies within 3 standard deviation of the mean. So what we're doing for this problem is we're trying to find the percent, or what the proportion of packages between, way between 10 and 14 pounds. So what we're trying to do is find the percentage that would be between 10 and 14. So I went ahead and drew this out. This isn't exactly the normal distribution curve that I'm going to draw, but it's like the rough estimate of it for now. So we're going to find between 10 and 14 pounds. So 10 is going to be here, and 14 is here. Right, yeah, 10 and 14. So between 10 and 14 is going to be roughly 68%. Because 12 is that, 12 is going to be that middle point. So between, these are a little off actually, these need to be moved back one. But really it would be this 34 and this 34. So between 10 and 14, this is going to be about 68%. Alright, and then moving to the next question, let's see, what proportion weighs more than 16 pounds? So then we're going to move to this 16 right here, and just go above, and that's roughly, I think, 2.5, I believe? Yeah, 2.5. So that's roughly 2.5% above 16. And then the third part is a sketch. So yeah, I already did that then, because I basically did this sketch. I'll start, I'll do this right here actually. I'll speed this part up. between 10 and 14, this is going to be our 68%. And then we'll go from 16 to there. And that is going to be our 2.5%. Alright, so starting with problem number 4, I went ahead and wrote out the mean and the standard deviation and the formula that we're going to use. And then first, we're going to use the z-table to find this. So it'll be 0. And I have my z-table up, so find that real quick. So it's going to be approximately 1.2816. And then now we're going to go back to the SAT scale, and we're going to use this formula right here. So if you plug in all of these numbers, we will get, let's see, so it'll be 500 plus 1.2816 times 100. And then, let's see, I have a calculator. So we'll do 500, actually, let's do this first. 1.2816 times 100 plus 500. Alright, so we got from that, we got 628.16. So a score of around 628 would mark that top 10%. So let's write that right here. So around 628 would be that. So next we're going to find the bottom half. So the bottom half is 25% below the cutoff, so the 25 percentile. So again, using that z-table, let's see, so we're going to do the z of 0.25, roughly negative 0.6745, and then we're going to do the same thing up here that we did. We're going to use this formula right here. So we're going to use this one right here. So we will have 500 plus that negative 0.6745 times 100. And that is equal to, let's do that on my calculator. Alright, so that will be roughly 432.55. So, and then, without rounding, I would say, yeah, I would just keep this at this number right here. I would just keep it at the 432, just because that's easier, in my opinion. You could round up to make this a 6, so I guess we could do that. So the answer for the bottom would be 432, and you got 0.6. And I guess here you do that 0.2.